We are joined by Dr. T.V. Venkateshwara, a senior scientist at Vigyan Prasar. We will be discussing the upcoming developments in India's space mission, and especially with the Chandrayaan-3 spacecraft nearing the lunar orbit, what it means for the mission and also the future of Indian spacecraft. So welcome to the show, sir. So the first question that I would like to ask you is that how does a successful maneuvering of the Chandrayaan-3 around the moon from the Earth's orbit, set a stage for the setting of the soft landing?
Okay. Let's imagine there is a helicopter that is flying above, and you are throwing something from below, and then somebody in the helicopter has to catch it. So the first thing is, when you throw, when the object that you want to catch is around the height of the helicopter should reach the same point, number one. Number two, if the object is going up and then you are trying to catch, it's very difficult, right? So the object has to go up and then fall down, and while falling down you will have to catch, right? That's what will be easy. That's the kind of thing that's happening right now. Now the moon is a helicopter. Your ball that you are trying to throw to the helicopter is actually your Chandrayaan-3. So the Chandrayaan-3 will slightly go above the moon and then come back. I mean, moon means moon distance and come back. While it's coming back, it will come very near to the moon. That's when it will start orbiting the moon. That's why you have to do a particular maneuver so that it will be captured into the orbit of the moon. That's a kind of let's say tricky stuff here.
Okay. So, sir, if we were to talk about if you can actually brief us about the elaborate payloads that the Chandrayaan-3 spacecraft has carried, and also, how it will help in the future experiments.
Yeah. Okay. So, if you look at the lander is carrying essentially 4 payloads for doing research on the surface of the moon. One payload is trying to find out the thermal conductivity. In school, we have done some experiments, like, for example, what is the thermal conductivity of a metal, what is the thermal conductivity of a wood. You heat on one side and then see that how much heat is coming on the other side, how long it takes, and so on. Essentially something similar. So there is a heat probe, there is a sensor probe. So both of them will go into the soil of lunar soil, and then this will heat up, and then you will see that how much time it takes for the heat to come here and how much heat is coming in, etc. So that you'll do a thermal conductivity study on the moon. That's number one. Number two, like there is earthquake, there is also something called as a moonquake. But of course, the moonquake happens because of a very different reason. The moon is cooling down. So when it is cooling down, it is shrinking. And when you shrink, you have, even when you are aging, and then your skin kind of wrinkles appear because of shrinking, right? The same way on the moon surface, there are wrinkles appearing. So whenever that wrinkles are appearing, you will have a quake. Okay? So this will study the moonquakes. So this is second one. Now, of course, moonquake can also happen because of falling of a meteor on the moon. Anyhow, so it will look at the moon's quake. By studying mooncake, you can understand what is inside the moon. I mean, it's a kind of a probe to understand what's inside the moon. The third one is a very interesting, let's say, piece of payload. It's just a mirror, not an ordinary mirror. It's called a retroreflector mirror. So if you send a pulse of laser, it will go hit there and then come back. By computing the time taken for the laser to go and come back, you can very precisely measure the distance of the moon. So you can do a lot of studies with regard to the Earth-Moon system, fundamental research on nature of gravitation, and so on. So this is a third experiment which is there in the lander. And the fourth one is what's called as a plasma experiment. Basically, near the surface of moon, there is something called plasma. In school we have studied 3 states of matter, liquid, water, and gas. There is also a fourth state called as plasma. Basically, the atoms don't have any electrons around them. Okay, because of radiation from sun, there is a very thin plasma layer near the surface of the moon that will be studied by this fourth payload. These are the 4 payloads on the lander. If you look at the rover, it's like a toy car which will go on the surface of the moon. There are 2 interesting probes. Okay, one is to find the elemental composition. The other is also to find mineral composition. So basically, they are all kind of spectroscopes. Okay, the one will use a laser to evaporate, and then from that evaporation find out the elemental composition. The other one will use some other inducement to make this lunar soil to emit radiation, capturing that radiation through spectroscopy. It will try to identify. This one has a very interesting, important point. The Chandrayaan-2, the orbiter, had what is called as a moon mineralogy mapper. So from remote sensing, we have mapped the moon. But how far we can trust it? You need some ground truthing. So the ground truthing will be done by this rover. So if the mineralogy mapper and what the rover finds are very close, then you will have much more confidence on the results obtained by the the earlier orbiter. That's the point. These are the 6 which are in this. There is a very 7th one, very interesting payload which is in the propulsion module. It will work only for a few months. It will basically look at Earth and then look at what kinds of chemical signatures are coming from Earth. So see, Earth is a planet with living organisms. So which means that there is a constant generation of oxygen and consumption of carbon, and then again carbon dioxide, and there is a cycle between carbon dioxide and oxygen, right? So like this, there are various such cycles. They all will send some signals. These are all called as biosignatures. So assume that you are going to look at some other alien planet. You want to know if that alien planet has life from distance. This is how you will do it. So this instrument will be like one of its kind. One of the, let's say, very advanced instrument with which one is trying to find out whether one can define certain biomarkers, biosignatures, and then how to find those biosignatures. These are the 7 payloads in this instrument.
Right. One of the very interesting things that Dr. T.V. Venkateswaran mentioned is the Moonquake. I was just coming to that aspect. Basically, one of the stated objectives of the mission is to study and detect the moonquakes, so that our future study is aligned to that, and also the geological surface of the moon. So could you elaborate a little bit on that?
See, on Earth, the earthquakes occurs because on the surface of the Earth, okay, we are all like floating on pieces. Underneath our hard surface, there is a molten substance on which these pieces are moving. So when these pieces are colliding with each other, or when they are kind of scraping past each other, you have earthquakes and volcanoes. That's how these happens on Earth. But whereas the nature of moonquakes are either there is a huge impact of a meteor falling on moon, or the moon is shrinking. Because of the shrinking, there are wrinkles forming. That wrinkles create moonquakes. Okay, so by studying the moonquake, where it is originated, how far, how it traveled, what kind of reflection it produced, you can kind of understand what is inside the moon, the composition inside the moon in terms of density and so on. That's the objective.
Right. So, if we have to talk about the Chandrayaan-2 mission, it was partly a success or partly a failure. So if you were to take the positives away from the mission, and what we actually learned, and what did we imbibe in the 3rd mission, so what are those aspects that we could take away from the 2nd mission?
Yeah, so for example, the orbiter of Chandrayaan-2 has done moon mineralogy mapping. So the lander and the rover will check whether those things are correct, the ground truthing. So we will know, for example, the orbiter is, the remote sensing is, how good is that data. You will be able to make an evaluation of it. That's one important stuff. Second, in terms of the craft, their landing, the AI in this, there is artificial intelligence in this for landing. They have made lots of improvement so that this time it's fail safe. In fact, Dr. Somnath said that we imagined every failure and said that, okay, let's have a solution for it. So our purpose is land. So we imagined every failure and then we have worked ways around it. That's what he has said. And they have done quite a lot of work, quite a lot of experimentation for this, and then This time we are very confident that we'll be able to land. Today we are going to have a very important maneuver, that is lunar orbit insertion. So it's something like, for example, the moon is going to catch the Chandrayaan and make it orbit around it. That's what is going to happen today. Till 17th, August 17th, the orbit will be made smaller and smaller and reduced to a size of 100 kilometers from the surface, a circular orbit of 100 kilometers from the surface of the moon. That's the thing that has to happen, and after that the landing will happen. So today's mission is very crucial in the sense that the moon has to actually catch it. The right time we'll have to fire so that it gets into the orbit. So we'll know, I mean, we have done it twice earlier and we have done it with Mars. So in some sense we are kind of familiar with it.
Thank you, Dr. Venkateshwara, for speaking to the Federal. And this is Siddharth Chakravarti reporting for the Federal from Chennai.
Subscribe to the Federal's YouTube page for more news and updates.